Right now, the most violent weather system on the planet isn't spinning anywhere near Florida, and it isn't sitting off the coast of Mexico. It's grinding across the open water of the Western Pacific, and it's aimed straight at a chain of small islands that belong to the United States. A Category 5 monster has locked onto Guam and the Northern Mariana Islands, packing sustained winds well past 175 miles an hour. Here's the part that turns this from a bad forecast into a genuine emergency. These same islands are still picking up the pieces from a different super typhoon that tore through only 3 months ago. That means we're not looking at one disaster. We're looking at 2 catastrophic storms hitting the same fragile communities in a single year, and there's a real chance the second one lands harder than the first. In this video, we're going through the entire timeline. Where this storm came from, how it exploded in strength so quickly, what actually happened on the ground when it made landfall, and where it's headed once it leaves the Marianas behind. No speculation, no filler, just the sequence of events and the numbers behind them. If breakdowns like this are useful to you, hit subscribe and turn on notifications so you catch the next one the moment it's posted. And if you want more people to see coverage like this, a quick like helps push it further. Now, let's get into it. Every major typhoon begins as almost nothing. In the final days of June 2026, forecasters were watching an unremarkable patch of tropical convection sitting east of the Philippines. There was nothing about it that stood out. It had no name, no defined center, and no real organization. By July the 2nd, agencies tracking the Western Pacific season had upgraded it to an early-stage tropical system, but it was still loosely wrapped and easy to overlook if you weren't paying close attention. That changed within 48 hours. On July 3rd, the Joint Typhoon Warning Center in Hawaii gave the system a name and immediately flagged it as a candidate for rapid strengthening. At that point, it was crawling west-northwest at roughly 12 miles an hour, steered by a ridge of high pressure sitting to its northeast. Nothing about its motion was dramatic. What was dramatic was the environment it was moving into. Unusually warm water reaching deep below the surface, minimal wind shear to disrupt its structure, and a saturated atmosphere feeding it moisture from every direction. Meteorologists reviewing the early satellite passes said the setup looked almost engineered to produce something historic, and forecasters covering the story for outlets like Yale Climate Connections were already warning that the system looked capable of reaching Category 4 or 5 strength within a single day of its first advisory. And what happened next is the part meteorologists keep coming back to. In a span of roughly 2 days, a storm that barely qualified as organized became a full Category 5 super typhoon with sustained winds near 165 miles an hour and a symmetrical eye stretching about 21 miles across. That is the textbook definition of rapid intensification, and it's a phrase that keeps showing up more often in tropical forecasting than it used to. The science behind it is simple, even though the storm itself was not. A tropical cyclone works like an engine that runs on heat. It draws warm, humid air off the ocean surface, carries it upward into towering thunderstorm clusters, and releases the stored energy as that moisture condenses at altitude. Feed that engine warmer water, and it runs harder. The stretch of Pacific this storm crossed was carrying exceptional heat content, and June of 2026 had just been confirmed as the second warmest June ever recorded globally, with the planet's average surface temperature sitting about 1.39 degrees Celsius above pre-industrial levels, according to the Copernicus Climate Change Service. That anomaly wasn't abstract. It was direct fuel for what happened over the following 2 days. To understand why this second storm was such a nightmare scenario, you have to go back 3 months. On April 14th, 2026, a separate super typhoon made a direct hit on the Northern Marianas, with its wide eye passing over Tinian and Saipan at the same time. At its peak, that storm carried sustained winds near 185 miles an hour and a central pressure that bottomed out around 890 millibars, placing it among the most intense typhoons ever measured in the Western Pacific Basin. What made that April storm especially punishing was its speed, or lack of it. It crawled through the region slowly, which meant instead of a quick, violent pass, the islands endured hours of sustained battering. More than 20 inches of rain fell in places, flooding was widespread, the power grid across Tinian and Saipan was knocked out, and structural damage stacked up across the region. When the final numbers came in, total damage across Guam and the Northern Marianas was estimated near $1.5 billion, and 6 people lost their lives, including crew members aboard a cargo vessel that capsized near Pagan Island during the worst of the storm. 2.5 months later, when this new system began organizing, large parts of Tinian and Saipan still didn't have reliable electricity. Shelters that should have closed months earlier were still housing displaced families. Homes still had tarps where roofs used to be. And now a second Category 5 system was tracking toward the exact same geography, with early guidance suggesting it could be even stronger than the storm that came before it. As the new storm closed in, NPR reported that shelters across the islands were already full and turning people away before the worst conditions had even arrived. A local emergency official told reporters that northern Guam had entire neighborhoods built from substandard materials, and that reports coming out of Saipan and Tinian described the situation as dire. The National Weather Service didn't soften its language either, calling the approaching system an extremely dangerous and life-threatening event. One Guam government official put it bluntly to the press. The goal was 0 fatalities. And he said he genuinely hoped that's how it would turn out, because the night and day ahead were going to be rough. Guam's Port Authority suspended all operations. Schools and hospitals braced for disruption. Andersen Air Force Base, one of the most strategically important American installations anywhere in the Pacific, ordered all non-essential personnel off base. This wasn't just a regional weather event. It was a threat to U.S. military infrastructure at the heart of the Pacific Theater. The hardest part for forecasters in the final days wasn't predicting the intensity. It was predicting exactly where the eye would go. American model guidance pointed the center directly at Tinian and Saipan, the same 2 islands, still recovering from April. European model guidance shifted the track further south, putting Rota and Guam in the crosshairs instead. Under one scenario, Tinian and Saipan would take a direct eye wall hit, while Guam saw only strong tropical storm conditions. Under the other, Rota and Guam would absorb the worst of it, while Tinian and Saipan escaped with typhoon level but not catastrophic impacts. Either way, someone was about to have an extremely bad day. The only real question was who. The answer came on the morning of Monday, July 6th, local time, when the eye passed directly over Rota, a small island of roughly 2,000 people sitting about 40 miles northeast of Guam. Sustained winds on Rota topped 150 miles an hour as the eye wall moved overhead. Local officials reported major damage almost immediately, though a full assessment was delayed because communications on the island were severely disrupted. Guam, sitting roughly 50 miles southwest of Rota, recorded wind gusts up to 111 miles an hour. Saipan logged the same figure. Guam's international airport also set a new single-day rainfall record, logging just over 12.5 inches in 24 hours. Communication blackouts, downed power lines, and structural damage were reported across all 4 islands in the hours that followed. Terms like Category 5 and Super Typhoon get thrown around so often that they can start to lose their weight. So here's what they actually mean. A storm crosses into hurricane-strength territory once sustained winds hit 74 miles an hour. It becomes a Category 5 once winds reach 157 miles an hour. This storm was measured at 175 miles an hour and higher at its peak, comfortably past the Category 5 threshold and sitting near the upper edge of what's physically possible for a tropical system. Central pressure tells the same story from a different angle. The lower the pressure, the more violent the storm. Forecast models had this system bottoming out near 910 millibars as it approached the islands. For comparison, the most intense typhoon ever recorded, Typhoon Tip in 1979, measured 870 millibars. The April storm that hit Tinian and Saipan touched 890 millibars. A reading of 910 millibars puts this storm firmly in the same historically extreme category. Satellite imagery captured by the Copernicus Sentinel-3 satellite on July 6th showed the eye sitting almost directly over Rota, with surface winds there exceeding 240 kilometers an hour, while dense cloud cover completely blotted out Guam, Tinian, and Saipan from view. Rainfall projections were just as alarming. The National Weather Service forecast roughly 10 inches of rain across the region, with some areas expected to see up to 18 inches depending on how close they sat to the eye wall. And then there's storm surge, the wall of ocean water a storm's winds shove onto the coastline, which is historically the single deadliest element of any major tropical cyclone. A storm of this intensity striking low, lying coastal terrain can generate surge heights of 20 feet or more, enough to overwhelm almost any structure standing directly in its path. Here's the part of this story that genuinely stands out. Despite winds over 150 miles an hour tearing directly across an island of 2,000 people, despite widespread structural damage, and despite communication blackouts that made damage assessment difficult for hours. As of the latest reporting, there were 0 confirmed deaths on Guam or anywhere in the northern Marianas from this storm. That outcome isn't luck, it's the direct result of preparation. Warnings went out days before the storm arrived. Evacuation orders were issued early. Shelters opened across the region, even though they quickly filled beyond capacity. Ports shut down operations in advance. Military installations moved to full readiness, and the public messaging was consistent and direct. Get to a safe location before conditions deteriorate, stay indoors once the wind starts building, and treat an approaching eye wall the way you'd treat an incoming tornado. Get to an interior room and stay there. That kind of clear, urgent, non-alarmist communication, combined with communities that unfortunately have plenty of experience with typhoons, is exactly why these islands made it through without adding to the death toll. It's the same principle Japan demonstrates after every major earthquake. The intensity of the disaster is set by nature, but the survival rate is set by human preparation made well in advance. The story doesn't end at Rota. After crossing the Marianas, the storm continued westward at around 9 miles an hour into the Philippine Sea, still carrying sustained winds above 150 miles an hour. The Western Pacific offers an enormous stretch of warm open water, which allowed the system to hold onto much of its strength well after making landfall. Forecasters expect a gradual weakening as it pushes west and eventually northwest, moving into cooler water and higher wind shear. Even so, it's projected to remain a powerful typhoon, roughly equivalent to a Category 2 hurricane, by the time it nears Taiwan, with landfall expected around July 11th before the system pushes on into mainland China at reduced but still meaningful strength. Taiwan's mountainous terrain is a serious concern here because it forces incoming moisture upward, dramatically amplifying rainfall totals and raising the risk of flash flooding, and landslides even after wind speeds have dropped well below super typhoon levels. Once it reaches China's coastline, additional flooding and wind impacts are expected across a wide stretch of coastal territory. Storms crossing the Philippine Sea toward Taiwan and China in late July aren't unusual. The Western Pacific season peaks statistically between July and October. What makes this system worth watching closely is the combination of how intense it became over open water, and the fact that it arrived on the heels of an April storm that had already inflicted an estimated $1.5 billion in damage on communities that hadn't finished recovering. A separate, much weaker tropical system was also being tracked, heading toward China around the same time, expected to bring somewhere between 100 and 200 millimeters of rain to the coast before dissipating. Smaller and less dangerous, but part of the same unusually active stretch of weather. Forecasters were additionally watching the Bay of Bengal for signs of a completely separate system potentially forming in the following days. You can't watch two super typhoons hit the same small island chain in the same year without asking the bigger question, is this becoming the pattern, and what's actually driving it? The honest answer avoids oversimplifying in either direction. The overall number of tropical cyclones forming globally each year hasn't shifted dramatically compared to historical records. What has shifted is the proportion of storms that reach Category 4 and 5 intensity. The storms capable of reaching major hurricane strength are doing it faster, holding that strength longer, and in some cases, intensifying closer to populated coastlines than older historical patterns would have predicted. The mechanism driving that shift is straightforward physics rather than guesswork. Tropical cyclones run on ocean heat. Warmer water means more available energy, and more available energy means a higher ceiling on how strong a storm can get. Sea surface temperatures across the Western Pacific, the most active typhoon basin on the planet, have consistently trended above historical averages in recent years, which lines up with the broader pattern of ocean warming confirmed by agencies tracking global climate data. June 2026. Being the second warmest June on record globally isn't a coincidence sitting next to this storm's rapid strengthening. It's part of the same underlying trend. Rapid intensification specifically is worrying to emergency planners because it shrinks the amount of warning time coastal communities get. A storm that takes 5 days to slowly build to Category 5. Strength gives emergency managers 5 days of escalating lead time to move people to safety. A storm that jumps from tropical storm to Category 5 in about 48 hours while still hundreds of miles from shore compresses that window dramatically. In this case, forecasters caught the intensification early enough that Guam and the Northern Marianas still had several days of lead time, which is a major reason the death toll stayed at 0. But that margin isn't guaranteed every time, especially for tiny, remote island communities with limited infrastructure to begin with. This wasn't an isolated event confined to one small island chain. The 2026 Western Pacific season had already produced 7 tropical cyclones by the time this storm made landfall, 3 of which had already reached land. A typical season in this basin produces somewhere between 25 and 30 named storms, and this one was tracking as an unusually active year, consistent with elevated sea surface temperatures and a weak La Niña pattern, conditions that historically favor increased typhoon activity in the Western Pacific. As the storm pushed toward Taiwan and China, authorities across the region were watching closely. The Philippines was monitoring its own exposure. Taiwanese officials were assessing timing and track. Southern Japan, including Kyushu, Shikoku, and central Honshu, was bracing for elevated rainfall totals even from the storm's outer moisture bands. Meanwhile, entirely separate monsoon rainfall was hitting parts of India, Thailand, Vietnam, Laos, Bangladesh, and Myanmar during the same stretch of days, part of a broader active pattern across Asia rather than a direct extension of this one storm. And forecasters were separately watching the Bay of Bengal, the world's second most active tropical cyclone basin during monsoon season, for early signs of new development. Whether you live in a typhoon-prone region or you're just watching from somewhere the storm will never reach, There are practical lessons buried in this event that apply every single season. Early warnings exist for a reason. Agencies like the Joint Typhoon Warning Center and National Weather Services issue advisories days ahead of landfall specifically to give people time to act. Waiting until a storm is a few hours away is waiting too long. Shelters save lives, even when they're uncomfortable and overcrowded. The fact that shelters across Guam and the Marianas were packed past capacity before the storm even arrived is a big part of why nobody died. If your home has already been damaged by a previous storm, or it's built from materials that won't hold up against extreme wind, moving to a shelter before conditions deteriorate isn't optional. Storm surge deserves the same respect as wind speed, if not more. Wind numbers get most of the attention because they're easy to repeat, but historically, storm surge is responsible for the majority of deaths in tropical cyclones worldwide. A Category 5 system approaching low-lying coastline can generate a wall of water 20 feet high or more, and that's simply not survivable in most structures caught directly in its path. And finally, have a communication plan before the storm arrives, not during it. Rhoda lost contact with the outside world for hours after the eye passed over, which made it harder for emergency responders to know where help was needed most. A pre-arranged check-in plan with family and a shared understanding of where everyone will shelter cuts down on panic and speeds up the response when communication networks go down. It's also worth remembering the human scale behind these islands, because it's easy to lose that in a conversation about wind speeds and pressure readings. The Northern Marianas are a chain of 14 islands covering roughly 180 square miles of land in total. Saipan is the largest, home to around 48,000 people. Tinian holds close to 3,500 residents, and Rhoda, the island that took the direct hit this time, is home to about 2,000 people. Guam, a separate U.S. territory sitting about 40 miles southwest of Rhoda, has a population near 160,000. These are small, remote communities cut off from major supply chains by thousands of miles of open ocean, which means every generator, every utility pole, every piece of construction equipment needed for rebuilding has to be shipped or flown in across enormous distances. When a storm this size damages roads, ports, hospitals, and power infrastructure in a place like that, recovery is measured in months, not weeks. And when a second storm arrives before that recovery is finished, the damage doesn't just add up, it compounds. Here's the full picture in one pass. A storm that barely existed in early July exploded into one of the most powerful systems on the planet within 48 hours. It struck communities that were still rebuilding from a nearly identical disaster just 3 months earlier. Peak sustained winds reached beyond 175 miles an hour. Guam logged a new daily rainfall record. The eye passed directly over an island of 2,000 people with winds above 150 miles an hour. And through all of it, there were 0 confirmed deaths on Guam or anywhere in the Northern Marianas. That outcome wasn't luck. It was the direct result of early warnings, serious preparation, and communities that took the threat seriously because they'd already lived through the alternative. The Western Pacific typhoon season is far from finished, and the months ahead, August through October, historically bring the highest concentration of intense storms in this basin. More systems will form. More warnings will be issued. And the lesson from this one holds every single time. Prepare early, act decisively, and take every warning seriously because the storm decides how strong it gets, but the community decides how many people survive it. If you found this useful, share it with anyone in a typhoon-prone region, and drop a comment if you were personally affected by this storm or the one that came before it. Subscribe to stay updated as this system continues toward Taiwan and China. And as new development is tracked across the Pacific and the Bay of Bengal in the weeks ahead, stay safe out there.